Welcome to today's math lesson. We are going to make our way to Schoology, to your math course, and you want to scroll down to the bottom to find this week's assignments. If you will click on the October 4th through the 8th folder. By the way, this is our last week before fall break, so we made it through the first 9 weeks. We are going to take a look at our October 5th. If you were not here for October 4th, when you click on that folder, it's a discussion. It's not really truly a discussion, it's just informing you that you need to do your ALEKS knowledge check, and then that I would be posting a video for test corrections. So if you were not here today to get your test back, then you can get that as soon as you do get back. But the video for Unit 1 test corrections is on your Schoology page. So it would be the Unit 1 assessment, which we took in person if you were in person that day, and then a video for corrections as well. The video for test corrections has also been emailed out to your parents and you on Skyward, so you can view it there with a YouTube link, and it is on my YouTube channel as well. So, back to today's math. For October the 5th, you're going to go to the October the 5th folder. You will see Lesson 8, Sessions 1 through 3. So we're combining sessions still, trying to get caught up with our curriculum here. We are going to take a look at division today. So Lesson 8 is all about fluently dividing multi-digit numbers. And again, we see that use a standard algorithm. And then, of course, with our decimals, to also be able to still add, subtract, multiply, divide decimals, again, with standard algorithm. So as we're looking at our division today, before we get started on that, I want us to take a look at our start problem. So our start problem for today, we have two. Number 1 here says, study the net of a cube. So this is the net, and it says of a cube. What is the surface area of the net? So remember, surface area, we find the area of each surface, each face. So each of these boxes is a face on the cube, so you need to find the area of each one and add it all together. So pause the video and do that, and then come back. So when we do that, when we find the surface area of this cube, we know that one box is a 4 by 4. Well, to find the area of a square, we do length times width, right? So we want to do 4 times 4. And after we do that, we have 1, 2, 3, 4, 5, 6 of those boxes. So we want to multiply it times 6 to get our total surface area. So 4 times 4, well, that's going to be 16, and then 16 times 6. So you will want to do 16 times 6 as well to get your final answer. All right, then we have number 2. The net of a pyramid with a square base is shown. Well, a pyramid with a square base is a square pyramid. But again, surface area is what we're looking for. So we want to find the area of each face. So one of the faces here is your square. To find the area of a square, we have length times width. So we have a 12 here. Well, if it's a square, then every side is 12. So we have 12 times 12. That's going to give us a number, right? Then we have 1, 2, 3, 4 triangles. Well, the area of a triangle is 1/2 of your base times your height. Well, in this case, my base is this side of the square. Well, if this is 12, it's a square, this is going to be 12. So we have a base of 12, and then we have a height of 15. So we want to multiply 12 times 15, and we want to take half of that. Now, we have 1, 2, 3, 4 of those triangles. So when we do that, we want to multiply it times 4. So again, once you get that answer, make sure that you multiply it times 4. So we're going to figure out whatever that area is, 12 times 15, and then divide that by 2. Get that answer and then multiply it times 4. Once you have done that, you're going to add it together. You're going to add the area of all those triangles plus the area of the square. And that will give you your surface area for that square pyramid. All right, that brings us to a little notes section here. So we have some vocabulary. And in this, we need to know what the dividend, the quotient, and the divisor are in a division problem. So the dividend is going to be the number being divided. The quotient is your answer to your division problem, right? And then your divisor is going to be the number you are dividing by. So we're going to do a little sample over here. If we have 12 divided by 4, then 12, if we were putting this as long division, it would look like this, 12 divided by 4. So our dividend is the 12. Our divisor is the 4. And then when we find that answer, that would be our quotient. So those are our parts to a division problem. Then we have our steps for dividing. So to divide, we divide, multiply, subtract, bring down, remainder, or repeat. Sometimes you'll hear it referred to as daddy, mother, sister, brother, rover. That's your division family. There's even some cute videos on YouTube if you want to look those up with your division steps. Math Antics has great practice with long division if you're a little rusty with it. So just remember that those are our steps. That's our steps for our standard algorithm. And that's what our standard wants us moving into, is that standard algorithm. Now, you may or may not be familiar with that, and that's okay. We're going to be exploring the different ways that you guys know how to divide today. So we're going to do a try-it problem. It says, on Monday, a board game factory makes 25,650 game pieces. The game pieces are put into packages of 6 pieces each. How many packages of game pieces does the factory make on Monday? So first, we want to figure out, what is this problem about? So let's go back and look at it. On Monday, a board game factory makes. So we have a factory that makes board games, right? So that's what this is about, okay? It's about a factory that makes board games. The game pieces are put into packages. So we have a factory making board games, and they're putting the pieces in packages, right? How many packages of game pieces does the factory make on Monday? So we want to figure out how many packages of pieces the factory makes in one day, right? On Monday specifically. So we have a total amount of game pieces. And our total amount of game pieces is right here. So this is how many pieces they made on Monday, right? And it says the game pieces are put into packages of 6 each. Okay? So we have a large number of pieces, and we want to condense it down to 6 pieces in each group. So think about what we're going to be doing here. We have a large amount of pieces, 25,650 pieces, right? And we want to change, or we want to figure out how we can condense this so that there are 6 pieces in each group. So I want you to pause the video and try this problem out, and then come back and check it out on how to solve it, or see my strategy. And if you have time before you come back to this video with the try problem, try to explain to someone at home how it is that you solve this problem. So we have our game pieces. Specifically, we have 25,650. And we're dividing it so that there are 6 pieces in each group. If you were to draw a picture of this, you would have your whole number, right? 25,650. And you're breaking this up into 6 pieces and 6 pieces and 6 pieces and 6 pieces until you had all of your pieces in groups of 6. So that is what we would be doing here. So there's different ways to divide. One that I really liked when I taught 4th grade math and 5th grade math, especially in 5th grade math, because you get into double-digit divisors, and students tend to get a little overwhelmed with that. So breaking it down with that partial quotient really seemed to help. So we have 25,650 being divided by 6, because we want 6 pieces in each group. If I'm doing a partial quotient here, then what I'm going to do is I'm going to say, okay, 6 times something to get me as close as possible to 25,000. Okay, so I know that 6 times 4 is 24, right? So instead, I could say 6 times, instead of 4, what if I add 3 zeros? What is 6 times 4,000? Well, 6 times 4 is 24, right? And then I add 3 zeros. I guess me pretty close, right? So now I subtract. So 6 times 4,000 was 24,000. I subtract. 0 minus 0 is 0. 5 minus 0 is 5. 6 minus 0 is 6. And then 5 minus 4 is 1. And then, of course, your 2 minus 2 is 0. So now I've got 1,650, right? And I'm still dealing with 6. So now I can say, okay, 6 times something isn't going to get me close to 1, but 16. I can get pretty close to 16, right? By multiplying 6 times something. So 6 times 2 is 12. 6 times 3 is 18. 18 is too far. So let's do 6 times 2. 6 times 2 would be 12. But what if I did 6 times 200? All right, so I have 12, because that's 6 times 2, plus my 2 zeros, right? So now I'm subtracting 1,200. So I've got 0 minus 0 is 0, 5 minus 0 is 5, 6 minus 2 is 4, and then the 1 minus 1 is 1, right? Now I have 450. Well, I don't want to go like 6 close to 4. Probably don't want to do that. So let's try 45. So I know that 6 times 7 is 42, right? So if I have 6 times 70, then that would be 42 plus a 0, right? So I've got 420. That leaves me with 30. I know a basic fact with 6 and 30, right? 6 times 5 is 30. So I'm subtracting 30. and I get 0. All right, so I have no remainder here. Now, what I need to do next, if I'm doing this partial product here, is I want to look at all the things I multiplied 6 by. Well, I multiplied 6 by 4,000. I multiplied 6 times 200. I multiplied 6 times 70. And I multiplied 6 times 5. So I want to add all of that together. 4,000 plus 200 plus 70 plus 5. So I would have 4,275 packages of game pieces, because we want 6 in each package, and it wanted to know how many packages could we have. So the factory can produce 4,275 packages if each has 6 pieces. So that is partial quotient. There are other ways to work this. Some of you might have used the area model. So area model says that if you have a box and it has an area, right, it has an area of 25,650. So you would be taking that 25,650 and you would be breaking it into pieces that you could work with. You would just need to make sure that when you're breaking it up, that it's still working with factors that are going to get you what you need by using 6. So this side of your box is going to be 6. So you're multiplying 6 times something to get 25,650. So then you could say, okay, well, I know 6 times 4,000, right? That would be 24,000. So then I would come over here to the side and I would say, okay, minus 24,000, right? That would be 1,650. All right. And we would basically be doing the same thing that we did with partial product, but we're working it in boxes instead. So then I know, okay, 6 times, what did we say? 200, right? 6 times 200 would give me 1,200. I subtract that and I'm left with 450. So then I can break it apart even more, right? So I could go 6 times, what did we say, 70? 6 times 70 would be 420. I subtract that and I'm left with 30. So 420, right? And then 6 times 5 is going to give me the 30. So now I have found the area of the box, and I also have found my quotient, because if I add these together across the top, then I have now found that the factory can make 4,275 packages if they put them in groups of 6. So that would be area model. Typically not something that my students used to go to as their strategy for dividing. Partial product, yes, my students used that a lot before, but either works. And then some of you may have just went on with your standard algorithm, right? So you would have had 6 being divided into 25,650. So if you did it that way, then you're looking at, okay, you can't divide 2 by 6, but you could divide 25 divided by 6 would be 4. Subtract 24. 1, bring down your 6. 6 times 2 would be 12. Subtract bring down your 5. Then this would be 7 minus 42 would be 3. And then bring down your 0. And then times 5, and you would subtract your 30, right? All of those ways give you 4,275. So all of them are different ways that you can work these problems. What I want you to do is I want you to think about, okay, when I'm working these problems, what am I doing here? How are all of these strategies similar? How are they different? And hopefully what we're seeing is, especially with something like your standard algorithm here, which is in green, and then let's take a look back at partial product, right? So we said times 4,000, right? That would have been minus 24,000. And then that would have left us with 1,650. And then we had times 200. So minus 1,200 leaves you with 450. And then we timesed it by 70. So that would have been minus 420, which left us with 30. And then we times it by 5 and subtract 30 to get 0. So both of these are strategies, right? Hopefully what we're seeing is we're making some connections here that no matter which strategy you're using, place value plays a very important role in division. So we've got to start, we're always starting here, looking here in our largest place values, which is typically not something we usually do, right? With math, we're usually looking at our smallest place value, but we're starting up there in the larger place value to decide how to divide these things evenly. And hopefully you're noticing, okay, even if I'm looking at partial quotient here, I still have 25 and 24, right? 25, 24. And then here, if I was ignoring the other parts, I would have 16 and 12, 16 and 12. So there's those types of connections as well. Also notice that place values have to stay lined up. I didn't come outside of a place value. All of this stayed lined up with the place values that it belongs in. So when you're working division, just like you're working with anything else, you have to stay in those place values. And even here in my other strategy here, place values stay lined up. You can't work outside of the place values. You've got to deal with one place value at a time. So you start with that largest place value, deal with it, and then move on to the next place value, and then the next place value, and the next place value, until you've finished your process of division, right? So we want to make sure that we're making all of those connections with our problems. That is some different ways, different strategies to solve your triad problem. And then some things that we want to keep in mind when we're dividing, that there are all of those strategies, and hopefully you're finding one that is working for you. So we have some apply it problems. We have 6 apply it problems, and then if you have time, there are 2 more try it problems at the end of today's lesson, like I said, if you have time. So if we're looking at our apply it problems, it says members of a school band sell 1,680 bags of popcorn to raise money. There are 112 band members. Each band member sells the same number of bags. How many bags of popcorn does each band member sell? Show your work. So we have a school band selling popcorn. This is what the problem is about. There are 112 members. Each member sells the same. So let's picture this. Let's picture this in our mind. So we have bags of popcorn, and we have 112 members, and each member is selling the same amount of bags. So we're taking this large number of bags and we're sharing it into pieces, dividing it into pieces. okay? So when that happens, we are talking about division, all right? So we want to take 1,680 and we want to divide that by 112. And you can use whatever strategy you would like to use for this, okay? You're even welcome, if you're at home, to use a calculator to check your work, just to make sure that you're showing your work, okay? So you can rewind the video if you need to review a strategy. If you want, like I said, that's perfectly fine. Or you can just continue on with whatever's working for you. So we have 112 being divided into 1,680, right? So those are some large numbers and they can be intimidating. But if we break it down and we look at, okay, let's just do, we're just looking right now, we're starting at our largest place values, right? So we need at least 3 place values. So if we look at the first 3 place values, if we're looking at that, we've got 168. So we've got 112 being divided into 168. Well, if I just did that one time, right, then that would be minus 112. 8 minus 2 is 6. 6 minus 1 is 5, and the 1 minus 1 would be 0, right? Bring down my 0. So this would be our standard algorithm, okay? So now I'm going to figure out if 112 times something is going to give me 560. Well, I know that 2 times 5 will give me a 0 in my ones place, right? So let's try that out. Let's try 112 times 5, okay? So 5 times 2 is 10, 0, regroup your 1, right? 5 times 1 is 1, plus this 1 that you carried is 6. 5 times 1 is 5. So we have 560. Perfect. Exactly what we needed. So we have times 5, it's 560, and then we get 0. So each band member needs to sell 15 bags of popcorn. And again, you can use any strategy that you want to for this. Let's take a look at what this looks like with partial quotient. So we have 1,680 being divided by 112. And we decided that, okay, we could do times 1, right? If we do that, well, I'm sorry, we don't want to times 1. We want to times 10. All right. If we do that, then we get 1,120. We subtract that. So we get 0. 8 minus 2 is 6. And then 6 minus 1 is 5. 1 minus 1 is 0, right? So now we've got 560. So now we can do that times 5. We subtract 560 and we get 0. 10 plus 5 leaves us with 15 bags of popcorn. So each band member needs to sell 15 bags of popcorn. So that is 2 different strategies there for solving that problem. Let's take a look at number 8. Number 8 says Nathan incorrectly divides 33,947 by 83. So we have 33,947. So he copied that part correctly. And then he's dividing by 83. So it looks like he moved over. Let's see what he did here. So he moved over to the 9. So he had 339. And he said 83 times 4, right? 4 times 3 is 12. So 2, carry your 1. 4 times 8 is 32. Plus that 1 would be 33, right? So he got that part right. He's subtracting there. 9 minus 2 would be 7. And then bring down the 4. And it looks like he brought down the 4 and the 7. If we're using standard algorithm, which is what he started out using, then we don't want to bring down two numbers at once. We want to stick with one place value at a time. Remember how we talked about earlier when we were connecting those strategies? We deal with the largest place value and then move along as we go along. So that would be the mistake there. If we did 83 times 49, 83 times 9 and got 747, well, that's not really how we're going to find our answer there. So that would be his mistake. He brought down the 4 and the 7 at the same time, which is not the process with standard algorithm. So we want to bring down one number at a time. All right. You are going to now divide 62,208 divided by 36 and show your work. And what I want you to do is I want you to solve this one on your own and then share with somebody at home how you found your answer. So 62,208 divided by 36. And I do want you to try to use that standard algorithm if you can. But if you use partial quotient or even area model, it's not wrong, okay? But we do want to start moving toward that standard algorithm. So try this problem out on your own, share your work with somebody at home, and then come back and check it out on the video. So if we're looking at this problem, then we see that we have 62 here, right? So if we have 36 times 2, then we have 2 times 6 is 12, so 2 carry your 1. Then we have 2 times 3 is 6, plus 1 more is 72. So really, we can't really multiply by 2 here, but we can multiply by 1, right? We subtract 36. We want to borrow here 5. This would be 12. 12 minus 6 is 6, and then 5 minus 3 is 2, and then we want to bring down the 2. So now we have 36 times, as close as we can get to get us to 262. So I know that 3 times 4 is 12, 3 times 5 is 15. We're getting closer, right? 3 times 6 is 18. 3 times 7 is 21. And 3 times 8 would be 24. So let's try out 8. Let's see what we get here. All right. So we want to do 8 times 6 first, right? Well, I know that 6 times 7 is 42. If I add 8 to 42, if I add 6 to 42, that will give me 48. All right, so I would have an 8 down here, carry my 4. not 4 times 8. 8 times 3 is 24, plus 4 is going to give me 28. So that's too much. So let's try 36 times 7, right? 7 times 6. Well, 7 times 6 is 42, right? 2, carry your 4. 7 times 3 is 21, plus 4 is going to give you 25. It's pretty close to what we're looking for, right? So we're going to multiply times 7, 252. So we have 0, 1, 1, and then we're bringing down a 0. So now we have 1,100, and we're going to keep going until we get to our final answer here, but you're going to see how close you can get here. And then after you find this one, then make sure you do your next place value last to get your final quotient on this. And again, if you would like to go back and check with a calculator, you can, or if you have questions and you're just really not sure about what you're doing, please message me and I will answer them as best I can. All right, these last 3 apply it problems. We're going to look at what you're supposed to do in them, and then you're going to do them, all right? So number 7 says, what is the value of 8 and 25 hundredths divided by 66? Show your work. So we have 8 and 25 hundredths divided by 66. There are no decimal points in the divisor, so you're not moving the decimal over. You're just going to bring it straight up right where it is. So then you're looking at 82 divided by 66. So you're going to follow those division steps. So a 0 goes here in front of that decimal point. And like I said, you're working with 82. So you're going to see how many times 66 will go into 82. I'm pretty sure it's just going to be 1 time, but if you want to check it out to the side, you can. 6 times 2 is 12. 2 carry the 1. 6 times 2 is 12. Plus 1 is 1,332, right? So we just want 1 time, subtract 66, all right? So that would be a 7. This would be 12. 12 minus 6 is 6. And then 7 minus 6 is 1. And then bring down your 5. And then you want to keep going. So you want to say 165 divided by 66. And make your way to finding your quotient. Again, if you're not using standard algorithm, that's okay. We just want to start moving in that direction for using standard algorithm. All right, number 8. Jason says that 1,330 divided by 28 is what that should say, is equal to 47 and 1400ths. Do you agree? If so, show how Jason could have gotten his answer. If not, explain the mistake that Jason made and show how to find the correct quotient. So we have 1,330 divided by 28. And they're saying that this is the answer that you would get. So you're going to follow your standard algorithm steps to solve the division. Again, you're welcome to use a calculator to check or message me and ask a question if you need to. But you're going to find your quotient there and see if this is correct. If this is not correct, then you're going to try to figure out what his mistake might have been. Then we have number 9 here. Bianca is making necklaces for her friends. She has 6 3/10 meter of cord. Bianca cuts the cord into 14 equal pieces, 1 for each necklace. How long is each piece? Show your work. So we have a total amount of cord being cut, right? Getting smaller. So we're cutting it into 14 pieces. So we want to figure out how long each piece is by dividing. So you're going to divide here and get your quotient. And you're going to decide how long is each piece. So if you have any questions, again, please message me. I know I didn't go over every single answer to its fullest, but I do want us to make sure that we're trying some work on our own and not just sitting and getting answers. All right, guys? So if you have time, you can do the 2 try it problems here at the end. They're just for extra practice, some challenge questions for you. Like I said, if you have the time. If you don't, that's okay too. Also, remember to be working on your ALEKS topics for this week. So I will see you guys for our next session.